This week in the shop, our goal this week mostly is to make sure that the 20 valve cover passes all of its tests. What we're going to do is we're going to take the valve cover up to Willow Springs Raceway, go meet with Taka Aono, and put our valve cover on his school car that has a 20 valve engine. But before we can take the valve cover up there, there's a couple of things I need to do here first. When I started making these valve covers, I went online and tried to find a gasket set. The cylinder head that I'm using for my mock-up here was completely stripped and bare. I didn't have any gaskets and I didn't have any hardware for mounting the valve cover. So I went on Battle Garage's website and I ordered the valve cover gasket that goes around the bottom and the valve cover rubber seals that go around the spark plug tubes. But I had a hard time finding the grommets that go on top, as well as the nuts that hold down the valve cover to the cylinder head. So at that point, I kind of realized that maybe this is something that I can use as an opportunity for a new product. What I came up with was, I was able to source the factory grommets, these are actually aftermarket, but factory style grommets from a place in Australia, had them shipped here. This is what the factory one looks like. This is actually a steel piece on the top that has rubber installed into it. So this is steel over rubber and it's just all black. Now, I wasn't able to find the actual nuts that hold this on. So I 3D printed a nut and I was like, oh, I'll just make the nuts that go on here, and this is what the assembly would look like. But then I was thinking, why don't I just make a grommet and nut that is incorporated together and seal it with an O-ring? So that started with a design of this. So this is a bad 3D print of a nut and grommet put together. This ended up being a little bit too tall, so then I 3D printed a shorter one, and this passed the test. So then I machined one. And so this is made out of 12L14, has an O-ring seal on the bottom, and it will get zinc plated. So now that I made a bunch of these, I can install the valve cover onto Taka's school car. But after talking to Taka, I asked him, so what do you got going on for your breather setup on your school car valve cover? And he said that the valve cover is currently just ventilated to atmosphere. It means it goes to nothing. So for testing, I want to make sure that our baffles are working correctly. I need to find some way to monitor how much oil is coming out of the valve cover, so I need an oil catch can setup. So today's goal is to figure out what I can use as an oil catch can setup to bring it with me to Willow Springs tomorrow so I can install it on his school car. Here's a picture of what his school car engine setup looks like right now. So today, I brought my Corolla to the shop so that I can use it for mock-up, so that I can design an oil catch can setup that I can put on my car, so I know it'll fit on his car, so that we can go do the testing tomorrow. So here's what I'm working with for mock-up today. This is my own personal A86. This one has a Beams engine swap instead of a 20 valve, but the engine bay fitment is going to be all the same as his school car because he has both of the shock towers exposed on the sides here, just like mine. So probably what I'm going to do is I'm going to figure out some way to mount some sort of a catch can into this strut tower area. That way all I have to do is just bring a length of hose that can sort of wrap around and go to it, and I can bolt it onto his school car and we can figure out if our valve cover baffling works good. So when I get there, all I'll have to do is just bolt the catch can on, bolt the valve cover on, and then take it out for testing. This is a -10 weld-on fitting that has a hex shape on the outside. Instead of welding around the outside onto the top of the catch can lid, what I wanted to do is weld just the inside here, but that's difficult when you're attaching it to a billet or a machine top plate. So to be able to easily weld around this bottom boss that's sticking out, what I did is I machined the hex shape into the top of the cap on the catch can so that this can drop down into that hex, and that little boss is going to protrude out underneath the bottom, which is easy to weld around. It'll also make it look nicer on the outside, so there won't be a weld here. It'll look like the fitting is just sitting in the top. I made the design of the catch can as simple as possible because I only had a couple of hours to go from design to product. So with a single piece of billet, I just machined out a box that had a step down to a lower section so it would be easy to drain. After the first operation is done and the inside is pocketed out, the material was flipped over and then the bottom side of the catch can is machined. So here's the gist of what's going on with the catch can. Just finished machining the bottom. We finished the lid earlier. We got the -10 AN fitting that's going to drop into this hex, get welded on the bottom side. And then we need to attach this K&N 3/4 inch breather fitting to the top of it, something like that. And what I got to do is I got to make a hose barb fitting that's going to drop into this 3/4 inch hole so that I can weld that from the bottom side, but I want like a hose barb sticking up. So we need to turn a hose barb fitting on my little chucker lathe. The first step when turning a part is to face the front of it and to turn an outside diameter. This gives you two accurate faces that you can take measurements from for when you're machining the other dimensions. The first part of the fitting that I'm going to machine is the diameter that's going to slip into that 3/4 inch bore on the top plate of the catch can. So I'm just going to turn the diameter and keep checking it over until I get the 3/4 inch measurement that I need. Here I'm just fit checking it, and this part of the part is done. After the diameter checks out, then I can go back in and chamfer the leading edge because this is going to get welded. I want to have a chamfer on the bottom of it. After the chamfer is done, then I'm going to adjust my tool post at an angle so that I can create a chamfer on the back side. I can create a step so that the fitting doesn't slip all the way through the part. And then I can turn the diameter that the air filter is going to slip over, which is also 3/4 of an inch. Once all of my outside diameters are turned, then I'm going to drill the hole down the center. I'm going to start with a 3/8 spot drill to spot the center of the part, and then I'm going to swap it out for a 1/2 inch drill and drill all the way through. Adding a little bit of cutting fluid will help so that the chips don't stick to the drill or gum up the tip of the drill. This also leaves a little bit of a better finish on the inside of the hole. I like to slow down the RPM when I first start drilling. This will prevent any chattering on the face of the drill until the drill gets further into the part, and then I can speed up the RPM so that I can drill the rest of the hole. After the hole's done, then I'm going to go back in and I'm going to turn a lead in on the nose of the hose barb. So this is where the rubber part of the air filter is going to slip over a larger diameter before stepping down to the final 3/4 inch diameter that the hose clamp is going to hold on to. Once the total rough shape of the hose barb is finished, then I can come in with my part off tool and part it off. The last step to finishing the hose barb is to put a smaller collet down to that 3/4 inch diameter of the bottom of the hose barb and just face off the nose and deburr it. Here's the finished hose barb fitting. You can see the two larger diameters, the one on the nose for the air filter to slip over so that it can be clamped down, and the second so that it doesn't fall all the way through the top plate. So here's the roughly assembled breather catch can. Now we can go put it over into the car because I was sort of guessing on the fitment of this. I loosely designed it off of the Corolla overflow bottle, which goes in the same position. So the job now is to figure out its best exact location and then make a bracket that holds it in the car. Then I got to run over to the hardware store and go grab a drain fitting that I can just drill and tap into the bottom. So after machining the catch can, the next thing to do was figure out how to attach it to the car. Because I was sort of in a rush to get this done as quickly as possible, I needed a catch can that was very simple to make, so I just sort of made a box. But that was negating any mounting brackets or threaded holes or anything to attach it. So really the only thing that I could do was weld a bracket to it, which I didn't want to do, or use the existing threaded holes as a way of attaching it. So I came up with this 90-degree angular bracket that uses the bolt pattern of the cap that goes over the top of this. And so I can use a sealant when I attach this together, and it gives me locating holes to attach it to. Now, where this is going to go is where I was showing you on the strut tower. So it'll go here. I can bolt that on, and then the catch can will screw together onto this bracket. That way I don't need access to the holes after the catch can is assembled. So this will get bolted first, and then the catch can will sandwich this bracket holding it into the car. I'll show you what I mean. So here's the bracket mounted up on a strut tower, and then I can just take my catch can and attach it like that, and then screw the top on, and it'll be held into place. So here it is in place. It almost looks like there's no bracket holding it, which is kind of cool. So now we got to weld some fittings on. So here's the two fittings set into the top plate, and I'll flip it over. You can see I was able to control the length on the barb fitting, so it sticks through a little bit, which will make welding real easy. The AN fitting, even though I thinned out the plate as thin as I could on the base, I'm not getting too much protrusion, which is okay. What I'm going to do is I'll chamfer the edge on the fitting so it gives me a little gap that I can weld into. So here it is after cutting that chamfer on the lathe. Now you can see there's a channel that I can weld into, which means I'm not going to have to put as much heat into the plate to get penetration. It'll be a lot easier. So the first step before tacking them together is to just clean with a little bit of acetone and a rag that doesn't leave any debris onto your parts. After the part's clean, then I'm going to go ahead and preheat it with a torch. For this, I'm just using some MAP gas. You can see as I start to torch it, there begins to be condensation around the part. We want to heat the part so that all that condensation removes itself from the aluminum because it can contaminate the weld. We're also checking with the torch to make sure there is no debris or oils that are still in there. If there's still oil or debris in there, it'll start smoking. And if we see any smoke while we're doing this, then we know that we need to go back and clean it better. First, I'm going to tack them both in place, and then I'm going to go back and weld them. With the catch can completed, now it's time to make the trek to Willow Springs. It's about a 2.5 hour drive from Fallbrook up to Willow Springs, so I had to leave about 4 o'clock in the morning to make sure that I was there at 7 when the gates opened. The car that we're using for testing is a school car at Driftschool USA. Driftschool USA offers the opportunity to learn how to drift in all types of different cars, but fortunately they've got multiple A86s, and Taka was kind enough to let us use his 20-valve A86 for testing. Today he has a couple of students that are coming to use both his A86s that are naturally aspirated and some of the other school cars. A drift school is a great place for doing testing on a valve cover because most of the class is going to be doing donuts, figure eights, burnouts, and that type of thing. So lots of high RPM and switching G-forces back and forth, which would normally cause a lot of oil sloshing. The class begins at 9 a.m., so I got there at 7 so that I could take off the factory valve cover, get everything situated with some new RTV sealant, let it sit for about an hour, and then we could warm it up and make sure that there were no initial leaks. Initial warm-up showed no leaks at all, so it looked like we were going to be good to go get some testing done. Out on the track, they started with a stock 16-valve Corolla, doing burnouts and donuts and getting used to the A86 chassis, before switching over to this A86 chassis that had the blacktop 20-valve engine, which is probably about 40 horsepower more than the factory 16-valve one that they started with. After getting situated in the car, it was time to start warming up the tires and have a little bit of fun. After a little warm up in the car, then it was time for Taka to hop in the seat and show them how to keep the RPM high so that the wheel speed is kept up and the car can transition smoothly around the cones. It's a little known fact, but not only is Taka good at drifting, but he's also a dancing expert. Here he is showing these guys how to do the Pee Wee Herman dance. The lessons continued for about an hour non-stop with this car until they started switching over to the other higher powered cars. Overall, this was a great testing experience for the 20-valve valve cover. After all of the testing was done, then it was time to bring the car back into the pits, let it cool off, and check for leaks. I wasn't able to find any leaks at all around the valve cover, around the grommets that seal the valve cover, which was that new product idea that we had. And then after attempting to drain the catch can, realizing there wasn't a single drop of oil in the catch can after over an hour of drifting. Overall, a total success. Now that the testing is completed, I'm really confident in the ability of the baffle to keep all of the oil in the valve cover. Now we can go back and just adjust some of the programming to speed up the cycle time and adjust some of the surface finishes a little bit, and then we could start production on the pre-ordered valve covers. See you guys next week.